And everybody goes silent. We got 5 minutes still, right? Is that right? All right, cool. This is a 2381, right? Good. I've done that before. I've gone to the wrong class and started teaching, and no one says anything, and just back away slowly and pretend it was an experiment. So how are things? I'm trying to kill 5 minutes because there's always a straggler or two coming in here. By the way, the reason that I'm mic'd twice is I try to pipe these lectures to YouTube when I can. So this one is working. Sometimes it doesn't work. So right now it's live on YouTube, and there'll be a permanent recording of many of the lectures. Not all of them. It's not guaranteed, but I will try what I can. So right now it's hey, look at me, and hey, look at everyone. When wave to YouTube. Hi. You can watch yourself later on. And I'm pointing at the screen so the screen can see what the slides I'm on, even though it won't help you because it won't be clear, but you see, you can follow along and listen to the dulcet tones of my sexy voice. Laugh at that. Genuine. It's stats, okay? It's stats. The only way to get through stats is to not take it seriously. Otherwise, you're going to be bored out of your mind, and we don't want that. What a way to start off, telling you to be bored out of your mind. You're not. You're going to have fun. We're going to have fun this year. As much fun as we can get with statistics, on average. Those of you who didn't laugh, try not to be mean. Huh? Mean? Statistics? Yes, I'm in comedy mode. Mode? Statistics mode? Yeah? I feel like there's a divide between us, some kind of median. It's time yet? It's a tough crowd. All right. I think it's officially 1 o'clock, is it not? 2 minutes. You get 2 minutes of awkward silence. Something resembling awkward silence. This is all being recorded, by the way, and now this is not good. They're not all like this. I'm not medicated. Yeah. Is anybody in the wrong class, by the way? It always happens every year. Oh, somebody's in the wrong class, and they're too embarrassed to leave. Right? That's good enough. It's 1 o'clock in my world. Let's start. Okay. So, silence. We begin. Yeah, so there's always somebody's in the wrong class. And when I first started teaching, the first class I taught, every time I'd start, somebody in the back would get up and leave. Every single class, like 3 minutes in. And I want to tell them, you know it's always going to be me. It's not going to change. You know what you're getting. So it's like they're waiting this first couple of minutes to see if it'll be a different guy or something. And to this day, I don't know what the story was. There's always the same bunch of people wait 2 minutes in the class and leave. I don't get it. So if you're going to do that, just let me know why. Just because it preys on me. All right, so we're in hss2381C, which is a kind of statistics. We call it quantitative methods as a way not to use the word statistics because statistics is scary, as it should be. But that's what you're getting. You're getting how to use numbers in such a way. I told you, somebody walks in at the stroke of one. There you are. Here, breaking my rule, starting a minute early, and it's bit me in the ass. So, wait, no, we're going to go. No, come on, just come. No, you're on the video, so wave. I just wave. Hi. They're the late people. Remember them. There they go. All right. So, oh, look, one more person. I think you're barely on time. You're late. Oh, yeah, 1 o'clock. And my heart rate just went down. Okay. So, this class is Wednesdays and Fridays. This is where you are, obviously in the right place. Now, the way that I run things is The slides are available. They're on the website, as most professors add them on. Be aware that there's no requirement for us to give you these slides. We do so out of a courtesy. And the slides often aren't complete. So you really got to pay attention, make your own notes, ask the right questions, and be aware that you're responsible for the content whether or not you are here. And if you miss a class, that's fine. I don't care. You're adults. Just don't ask me to go over the content that you missed. It's your responsibility. Take your own notes. Don't get lazy. Okay. There are many sections of this class. This is section C. We try to cover the same stuff. We try to harmonize, we call it. In fact, this year, amazingly, for the first time ever, we've got the same marks breakdown for the assignments and exams, so for most of us anyway. But the classes are not interchangeable. So if you're studying with someone from one of the other sections, that's fine. Be aware that the exams will be different, the questions will be different, the philosophies and the expectations will be different as well. So the classes are not interchangeable. Right, so takeaway message there is feel free to interact with students from other sections, but be aware that the classes are not interchangeable. There's a textbook. That is the textbook. That's the textbook. Oh, great, this will work. Here we go. And there's a recommended textbook as well. It's not required. I know textbooks can be ridiculously expensive, so I understand you don't want to buy it. That's fine. And you can get used ones lots of places. We've been using the same textbook for several years, so there are lots of used copies kicking around, and maybe some bootleg ones online that I can't tell you about. But wink, wink, I'm sure they're out there. And I can't advocate for piracy, but wink, wink, I do. So you can find it. So this is how your marks breakdown will be this year. For the first time, I'm marking you in the labs. So the labs start next week. They are mandatory. I think the first one isn't. We'll give you a week leeway, but I recommend you attend. The TA runs the lab, Kahina, and every lab session you'll be given an assignment to complete in the lab. And each session comprises 2% of your final mark. There are 10 sessions for a total of 20%. Your midterm exam is 30, and final is 50. All the way to 100%. So I don't take attendance. Come if you like. I don't really care. That's great. I do care. I want you to come, right? And now that it's on YouTube, I understand if you'd rather watch it. Like in previous years, I've had students literally in another room watching me live on YouTube because they don't want to look at my face. I don't know. That's your business. Okay. But again, whether or not you attend, you're responsible for covering your class. The attendance in lectures is mandatory. That's not right. Lectures, I don't care. But the labs is mandatory. The reason for that is the lab space is expensive for us, and we reserved it specifically for you in small groups. So we want to make sure you're there to partake. And so the assignments you get them in the lab, only in the lab, not anywhere else. The labs are in MNT 141, I think. And I think you've already been broken down in groups of 10 or 20. Starts next week, and they're supervised by Kahina, and that's her email address. And she's a hard ass. So don't piss off Kahina. She's tough. I'm trying to scare you early on, so you come in there with the due fear and respect for her before you realize she's actually pretty soft. Like I said, there were 2% of the final mark each one, and this is the way I break it down. If you're there, if you just show up, you get a mark, right? If you attempt to complete the assignment, you get another half mark. And if you get it right, you get another half mark. So right away, it's a gimme. Look how obviously good that is. And the reason for that is we understand it's a learning environment. You're there to make mistakes and just to try. So we encourage you to try. Just try. Right? So in the lab, we're using one, possibly two statistical programs. I'll get to you in a second. And be aware that we are trying to get you to apply what you learn here in a real-life context in the lab. Some of what you learn in the lab will manifest in the exams a little bit, not a lot. But your lab experience is your chance to really kind of expand your brain and play a little bit. Both of the exams are multiple choice because we in health sciences are under-resourced and lazy. We want to hand mark written things. That's the reason, really. I mean, I'd love to be able to hand mark your stuff at the time. They don't give us enough TA hours to do so. So they're all multiple choice. And the final is not cumulative, meaning once you're done the midterm, you can erase that part of your brain and start anew. But I hope you don't. I hope you retain a lot of that stuff and at the end of the course have a full, majestic, orgasmic appreciation for all things statistics. But you know you won't. Low expectations. It'd be great. You're gonna every year really enjoy this class. Right, so I have an enormous teaching load this semester. I mean, it's crazy how many classes I'm teaching, so I'm not around a lot. So it might be kind of hard to find me, but I'm always willing to talk to you about anything you want, your careers, or you might be. I love that stuff, but I'm pretty hard to get hold of at time. So anything relating to the course, try the TA first. That's what she's here for. If you don't understand something or whatever, try her first, and if that doesn't work out, then she'll direct you to me. But otherwise, just email me. So I don't maintain office hours. I'm rarely on campus, so email me for employment. Like I said, I don't require attendance, but if you do come, pay attention. If you don't want to pay attention, leave. That's okay. I don't mind. If you're going to be on Facebook, just go elsewhere. I was a student. I remember what it was like. Sometimes you don't want to come. I understand that. Just don't be here. It's fine. If I passed you in the corridors, I recognize you. I won't say, why aren't you in class? I'll say, good for you. You got something better to do. Just don't, if you be here, be here. Right. I do not negotiate. This is a big one. This is a big thing with health science students. They're always, Professor, I deserve an A+. No, you don't. If you deserved an A+, you'd have an A+. The TA will not change marks for any reason except when there's been an error in the marking or when the question is clearly wrong. And if you think the question is clearly wrong and your answer is clearly right, then of course, come and see me or the TA. That's what we're here for. Fairness is really important. Fraud is a real thing on campus. I used to serve on the fraud committee. Always good times. Good to see students cry. Enjoy that. And I feel, my favorite episode was someone had plagiarized her ethics essay in nursing. And that was hilarious. You plagiarized an ethics essay. The irony. And no one else was laughing at that. They said this happens all the time. It happens all the time. You plagiarize ethics essay. So don't plagiarize your ethics essay. But also, fraud in a course like this would be, cheating during the exam or handing in a lab assignment for somebody else, that kind of stuff. Working to do. Obviously, it doesn't apply to you because you're so morally upstanding and wonderful people. I know for a fact I won't have any issues whatsoever. Right. So there's only one way to get marks, and that's through the exams and assignments. There's no makeup assignments, none of that stuff, so get that out of your mind right away. There's always one student every year who's Professor, I need 10 more marks, can I do something extra new? You can. And if you're going to miss assignments or exams, there's only one reason, and that's a medical issue with documentation or family tragedy of some kind. There's actually a paper I present students every year. There's a study that looked at the increase in prevalence of grandparent death around exam time. It's actually a real thing. And there's a great paper that looked at a significant increase in, especially grandmothers tend to die around exam time. And the conclusion is we need to have an intervention. Clearly, these grandmothers are at risk. Our grandmothers in the country are dropping like flies. So after years of problematic grandmother death in this faculty, we have a very formalized process now, and the department vets cases of family tragedy or medical documentation. That's not to say if you're sick, you should show up with your limb dangling from a tendon or something. No, get the documentation. Don't come. Be fine, right? I'd rather not get the flu from you. Stay home. We'll work it out later. But it does mean that if you got to go on vacation or something, I'm not going to accommodate you. It's only if the medical issues are involved. So I love this. I created this slide this year because it makes me laugh every time I get one of these emails. Professor, I got 89.4, and that's like 0.1% away from a 90. No, it's not. It's 0.1 for 85.5. But anyway, please, I need that 0.1. No, you can't have that 0.1. Especially in a class like this where every mark is accounted for with a multiple-choice question or a particular lab question. If it was an essay, then you can argue that the quality of my essay was more than you gave it. All right, maybe. Maybe, no, but maybe. But just don't bother. The solution to this is just to get the question right in the first place. All right. Any questions about the nature of the course? Now they've laid down the law that is me. Yeah? All right, cool. You regret taking this class now? Yeah, maybe a little bit? Yeah, okay, all right. So we're going to review. So I hate statistics. And I have a PhD in statistics. So what does that tell you? It tells you it's okay to hate statistics. It's all right. It doesn't have to be horrible. It doesn't have to be painful. Just embrace your pain and realize that there's a way to look at it that's kind of fun and interesting. We're going to try to find that fun, interesting way. So because you may have a dislike or disdain or hesitation or quandary surrounding the topic, put that aside. It's only going to slow you down. Consider this a brand new approach. And the way I'm going to teach this is to assume you've got no background whatsoever. So we're starting from first principles. Like I said, I'm going to broadcast the lectures when I can on YouTube. This is not an online class, so attendance is not mandatory, but it's expected. So if you don't get the video one day, you can't complain because it's an add-on. Right? Still going. The best part of this is I can actually tell who's watching. Right now, nobody's watching. Because I didn't advertise the fact that it's on, but in future lectures, I put a link on Facebook and stuff, and all kinds of people from outside of this class watch with us, sometimes from other countries, and it's great because I can tell, hey, Libyans are watching. How you doing? Okay, so let's talk about statistics. Actually, I didn't check my microphone. Good, it's working. Excellent. It'd be really bad if I'm recording and there's no actual sound. It's working here. Why do we care about statistics? We care because this is the foundation of all research. It really is. There are two worlds of analysis. There's the qualitative and the quantitative. There's a reason this course is called Quantitative Methods. We're dealing with the quantitative world. The qualitative world, we haven't got a course in that yet in this program. We're working on it. But the qualitative world you should know about. That's focus groups, that's interviews, that's thing called grounded theory and phenomenology, which you may have learned about in your research methods class that you took already or you're taking next year. How's it work now? Is it this year? Next year? Next year, okay. So that stuff we'll cover later. But there are qualitative researchers and quantitative researchers, and now we've got mixed methods people who do both. Right? So be aware they exist. We're going to talk about the quantitative world. And within the quantitative world, what we care about is this thing called statistics. Also, if you don't go into research, why do you care? You care because this allows you to understand how the world communicates information to you. And if you understand what I hope to be able to teach you this year, then you have less likely of a chance to be manipulated by untruthful individuals who are trying to purport to show you evidence that in fact the evidence is crap. Right, so this is why we care about statistics beyond simply being researchers. It's relevant to your role as a citizen going forth into this wonderful world. It begins way back in time. Obviously the use of numbers to count and to make predictions and to make analyses and conclusions goes back to the origins of civilization. Well into about 2000 BC, I would say the first manifestations of individuals formalizing a counting and analysis system. But the word statistics begins in the 1700s in Europe as accounts of the state, because it was used to figure out who owns what and what you owe the government. It all comes down to what you owe people. So statisticians, accountants, bookkeepers were sent around villages to figure out that guy's got 2 cows, he owes us this amount of milk for his tax purposes and whatsoever. By the way, this stuff is not going to be tested on this. This is weird. People are writing through saying, this is the thing. Relax. It's the math stuff I test you on. Okay, so the use of all this stuff goes back a long time. So we are engendering into a tradition with deep, deep roots that's still evolving. So in the last 200 years, there's been actually a remarkable revolution in new techniques of analyzing numbers to make conclusions and inferences and so forth. It's still evolving. The techniques that you're taught in high school, would have been taught in high school 20 years ago, are no longer taught because the technology has moved on. We've had better ways. What I was taught in graduate school, we no longer use some of those techniques because there are new ones now. Because the stuff I teach today may not exist in 10 years. Then why am I learning it now? You're learning it now because it exists now. We can use it now. In the last 50 years, there's another revolution. Computers came along, and that allows us to do things we never thought possible. I'm going to show you, as the course unfolds, a couple of instances where the important tests of the day came out of really surprising places. The Guinness Brewery actually was where a particular test came about. The t-test, which we'll learn about later on, was invented by the statistician making beer. So it was made to test the quality of Guinness beer. We'll get to that later. So it's Statistics has become the fundamental technique of a variety of disciplines, including mine, epidemiology. I'm an epidemiologist. Does anyone know what that is? Epidemiology? Yes, sir?
Essentially, you're looking at like longitudinal trends, so generally.
That's one thing we do.
That's
one of the things. Can you define it? Do you know what the term means? Nothing to do with skin. Everyone always says epidermis. No, there's no R in epidemiology. I do know some dermatological epidemiologists, and they have a really hard time the root word is epidemic, so we look at the spread of diseases originally, but really it's the application of statistics or numbers for the purposes of investigating health states. And one of the things we do is longitudinal data, always. Okay, so statistics is hard to define. I like this definition. It's a way of collecting, organizing, summarizing data for the purposes usually of making some kind of conclusion. Is there a difference between math and stats? What do you think? Yeah, opinions on this? There's no right or wrong answer. Obviously, this is not an exam question, so relax. What do you think? Is there a difference between math and stats? No opinion? Anybody? If you Google it, you find all these scholars arguing not for a difference between the two, but how the world responds to mathematicians versus statisticians. It's curious. We still don't know the differences. So I like one way of looking at it is mathematics is the logic of certainty. 2 + 2 = 4. I'm certain about that. I've seen it happen several times in my life. I add 2 things to 2 things. I get 4 things every single time, except that one time I was drunk, but we don't count that. But statistics is the logic of uncertainty. It's not knowing exactly what's going on. I'm going to collect some data over here and try to figure out, estimate what's going on. That's, I think, a fair way of looking at it. And I've forgotten why I put this graph here. Because these slides are old. But it was meant to demonstrate a difference between math and stats. So we've got the weights of members of the 2000 U.S. men's Olympic rowing team, and they're clustered in such a way. So we have the data, we have the numbers, their weights, which is math. We've collected. I can add them all up and get numbers. But their distribution tells me something. It says there's more of them who are heavy than there are light. And that's a statistical sort of conclusion. But the numbers themselves are mathematical, if that makes any sense. I like this. The difference between data and information. That's actually a pretty important distinction. So we have these numbers, 50, 52, and 56. They're just numbers. They mean nothing to you until I give you context. And the context, they happen to be the ages of Barack Obama, Stephen Hawking, Nicolas Sarkozy, back when he was Prime Minister of France. Right, so suddenly, these numbers have context. So this was something that will pop up again in your health sciences education. The difference between just numbers and information. Data is just things that we collect. It doesn't become information until we do something with it and figure out its context. So measurement we'll talk about as well. What's a measurement? A measurement is assigning a quantity to a quality. For example, how old are you? You say you're 25. What does that mean? It means that you have been on this planet since the moment of emerging from your mother, 25 revolutions around the sun. That's what that means. Is that useful? I don't know. It depends what you mean, why you're collecting it. 25 is a cutoff for to rent a car or not in Ontario, so now it has meaning. Okay, so we've measured this quality, we've assigned a value to it, a quantity, and now we're going to use that value to do something useful in society. If I didn't measure your value, you're still 25. You're still been on this planet a certain number of years. It didn't change the essence of what is you. What's your gender? Say you're female. Right now I've assigned a label, a quantity, a quality to you. You may argue that you're something other. You're gender fluid, or you feel masculine. I don't know. That's a political issue, right? An identity politics issue. So suddenly, by measuring something, we have constrained it to have a relevance and a role in our society we didn't have a second ago. So statistics is a little more than just applying numbers to things. It's actually a value-laden political context as well that subtly starts to manifest if you look at it carefully. Now, for some reason, these are supposed to be animated slides, and the red bits are supposed to come up as I press buttons. So none of my slides are animating today, which is a pain in the ass, but we're going to pretend that they are. So a variable has lots of different definitions depending upon your use. So in the math world, a variable is something that changes within the scope of a problem. So x equals 4, x equals whatever it might be. Okay? And we leave it as a blank because that's going to go through several registries as the mathematical sentence iterates. It's a logical set of attributes amongst research. What does that mean? Well, I'm going to collect these variables in my study. I'm going to figure out how many are men, how many over 25, and so forth. Or in computer programming, it's a symbolic register. So a string, if you know Visual Basic Programming, would be a variable name for a letter, like this, right? So in mathematics, x would be a variable, and research, age is a variable, and computers, a string. We have relationships between variables. So we can focus just on one variable. What's the average age of students here? Or we can focus on associations between variables. So in this class, is the average age of women different from the average age of men? Here, there are two variables in that sentence. What are the two variables? See them? Age and gender, correct. Okay, so that's an analysis, an analytical approach. That's a descriptive approach. That's a meaningless distinction. If you care about syntax, there it is, right? So I would say that's descriptive statistics, that's analytical statistics. I've done something with one variable, now I've shown a relationship between two of them. Describe, analyze, describe, analyze. Remember in high school mathematics, you had functions. So f of x equals 210 minus x, right? So this is a relationship maybe between age and maximum heart rate. So we'd say that your maximum heart rate is 210 minus, sorry, yes, what am I saying here? Max heart rate is, x is age, so 210 minus your age would be max heart rate. So suddenly we're applying values again to these mathematical sentences. If you remember your math, we have names for that relationship. The thing that's changing in response to our sentence, that's a dependent variable. It depends on what we do over here. The thing that's changing is the independent variable. It can be whatever it wants, independent. But the dependent variable is dependent on what we do with the independent variable. Do you remember that from high school? Good. All right. That's an important distinction. We're going to use that verbiage throughout a lot of different things in the course. So get it straight in your mind, the difference between dependent variable and independent variable. In the world of public health and epidemiology, it changes a little bit. We change these concepts to be outcome and exposure. So your exposure is the thing in public health that you're exposed to. The power lines, the asbestos, the fat in your burger, whatever it might be. The outcome could be your cholesterol levels or your risk of heart disease, whatever it might be. But mathematically, it's the same idea. A dependent relationship, an independent relationship. It's independent, really, how much you smoke. I mean, you have a role to play in that, but you can say you can smoke from 0 cigarettes to 1 billion cigarettes. But it's your risk of heart disease or lung disease is dependent on the independent range. So your cancer rate might be 210 minus your smoking rate. So smoking is the exposure, cancer is the outcome. What does that mean, 210 minus smoking? Maybe it's 210 minus the number of cigarettes smoking per week is the probability that you contract cancer that week. I don't know. I made up these numbers, don't quote them. Right, moving on. Well, I'm just zipping through a lot of things today because it's the introductory class and nobody cares. So we're going to make it fast and easy and light and get to the good stuff next class. But to start you off, we have to talk about the nature of variables and how we code variables. There are two general kinds of variables, continuous and categorical. There are actually 4 or 5 or 6 kinds of variables. So we're going to go more deep in that in a second. But we start with 2 general categories, continuous and categorical. A continuous variable is something like age, height, distance, temperature, what else? Weight, the circumference of your belly, whatever it might be, right? Those are continuous. Why do you think they're continuous? Do you see anything continuous about them? Yes, madam.
Because they're like decimal, because they don't have equal numbers.
Sort of. You're inching there a little bit, you know. Let me give you an idea. If I say you're 17 years old, does that have meaning? Yeah, it does. If I say you're 17.5 years old, does that have meaning? Yeah, it does. Can I say you're 17.54? Here, how about 17.542? Can I do that? Yes, I can. I can break this down into many smaller iterations. So does that help you distinguish the quality of a continuous variable? Yeah, I'm getting it? Yes, ma'am.
But you can never find the exact value.
That's true, actually. You can never find the exact value. That's not a distinguishing characteristic. The distinguishing characteristic is that it is literally continuous. I can keep on stretching it, and there's more stuff. There's more stuff in between. It's like water. It flows continuously. I can break it down into smaller bits of water all the time. As opposed to a categorical variable, also called a discrete variable, something like age, group, or gender, number of siblings. So I can say you've got 5 siblings. That makes sense. Can I say you got 5.5 siblings? No. Yeah, your sister might be really short, but she's still a whole person. Okay, or 5.54, so it doesn't make any sense. So I can't break that down further. They're discrete measurements. So that's the difference. There's categorical things that are discrete that can't be broken down, and continuous measurements that can be continually broken down to find little bits in between. Notice I have age here and age group. Oh, sorry, Cess?
I was just going to ask, which one's more precise?
Well, all right. So it's not a matter of precision. Sometimes you get what you get. Number of siblings, you can't make that continuous. In real life, that's what you get. However, the difference between age and age group, I got there a second, right? I'm measuring the same thing there. So let's say I send out a survey, my survey of this class, I have you write down your ages. And I look at, well, I've got like everything from 18 to 30 in this room, right? I've got 100 people in this room, I think, right? And I have this list. So I can keep in my Excel file under age, I can write down your actual age, make it continuous, or I can create an arbitrary distinction and say under 20, over 20. And I'll say, oh, you're 17, you're under 20, you're 35, you're over 20, and so forth. So this variable, this thing in my Excel file is now yes or no, or under 20, over 20, or 1 or 0. I've made it discrete. Now, which do you think is more useful? More useful, yes, because you can do more things with it. However, it may not be more useful in the story you're trying to tell. If I care whether or not you're over or under 25 because I work for Enterprise Rent-A-Car, and all I care about is are you legally able to rent a car at 25, then suddenly the discrete makes more sense. It's more useful. If I have no rationale for that, then the continuous makes more sense. I can compute a mean age. I can't compute a mean age group. Right, so yeah, you got me jumping ahead to an important point, which is when we move from continuous to discrete, we lose nuance, we lose wisdom, we lose ability, but we do it all the time. I don't like it. I advise people not to do it, but we do it anyway. It's particularly around age group, because it's easier to create discrete categories than continuous categories. Okay. So the most common types type of categorical data is dichotomous. Dichotomous means 2 categories, yes or no, male or female, on or off, old or young, short or tall, graduated, not graduated, undergrad, postgrad, whatever it might be, right? And we do this all the time. And we do it because psychologically, it's easy to deal with a register that's yes or no, on or off. Computers are binary, yes, no, it makes life much easier. A lot of our statistical techniques rely upon 2x2 tables, 2 levels associated with each other. We'll read about those later on. Your sex, your male, your female. Of course, politically now we have more categories of gender. Sex is not the same as gender. You covered that in your first year classes already, right? Got that down. So very often we dichotomize. So as I mentioned, we'll dichotomize, meaning convert from one state to a 2-level state. Age becomes age category. In the example I just gave you. Here we've got under 40, over 39. I could have said 25 and younger, or 26 and older for a car rental place. Or if you go to vote next month, they'll ask you, are you 18 or over, sir or madam? All they care about is that. You can be 99, they don't care. The upper limit's irrelevant to them. It's the 18 or less they care about. Okay. So dichotomizing is when we take something that wasn't 2 levels and make it 2 levels. We do it all the time. It's not good, but we do it all the time. And there'll be some analyses later on. I will ask you to dichotomize the data. to make it two levels. So, talking about levels of measurement, there are 4 that we care about that are in the textbook. And they are nominal, ordinal, integral, and ratio. Have you heard these terms before? Anybody? Good. Something new for everyone. Like you not. Oh, that's good. You heard it before? All right. Anyone else heard it before? So it's new for everyone except for her. That's good. All right, and it's not that important, but it's relevant in a way to think about how we choose statistical analyses. By the way, what I want for you in this course, at the end of this, you're not going to be statisticians. You're not going to be running around giving people advice on how to analyze their data. What I want from you is A, not to be afraid of statistics by the time December rolls around. B, be able to do 3 or 4 basic analyses that will teach you how to do. And lastly, be able to tell which analysis to do depending on the nature of the data. And the nature of the data really comes down to which of these measurements it is. So if you can identify in the data that you're given how the variables have been coded as one of these 4, that will allow you probably, most times, to select which of these 4 very basic analyses you will apply to them. That's really all you care about. When it comes, that's what most people can do in the real world. Non-statisticians posing as people who understand statistics, that's all they can really do. And that's actually a lot. So if you can do those things by December, you're great, you're fine. Okay. So let's start with the first one, nominal measurement. Think of the French, nom, right? It's a name. So if I collect all your names on my Excel spreadsheet, which is my data set, can I do anything with that? Can I do any math with that? What do you think? Give me an example of some kind of math I can do with a list of names. Yes?
The average number of letters.
Average number of letters. That's interesting. I never thought of that. Okay, yes, but now I'm not dealing with the names anymore. I'm dealing with the letters. The letters are not my data. So stick with this names. What can I do with the names? Math-wise. There's only really one thing or 2 things I can do with it. 2, yes? Is that a hand? Oh, sorry, you're doing this, so that was a hand. Okay. Let's see, I thought you were doing this.
Oh, we like alphabetizing?
Alphabetizing. I could alphabetize them, that's not a math thing.
But like explain how like the first half of the alphabet, the last half.
Okay, but now I've created a new variable, alphabet. So a name's not an alphabet. What can I do with just this variable? Yes.
How many people have the same name?
Okay, that's all I can do. I can count number of Johns, number of Marys, and so forth, right? I can give you the total number of names. I can do 2 things. That's it. So nominal data really isn't that useful by itself. So give me some more examples of nominal data. I can ask you what province you were born in. That's nominal data. The thing about nominal data is I can't really rank it. I can't say the Johns are better than the Marys. I can't say that Ontarios are better than Quebec, so you know they are. Right? I can't say, joking mostly. So I can't, and very often we can convert nominal to something resembling numeric, but here I can collect your sex, male, female, right, and apply 0 or 1s to it. Now it looks like numbers, it still isn't numbers, it's just category stuff, right? So we can't really do a lot with nominal data, but very often that's all we have. If you have, looking at an amateur collecting data in a survey, for example, often we'll write down opinions, or, you know, which drugs you take last week, or Tylenol, ibuprofen. I can't do anything with that information, you know, or who'd you vote for last time? I vote for this guy, whatever. I can't do a whole lot with that information mathematically. So nominal measurement is not our favorite kind of measurement, but it's very, very common. It exists. The next down is ordinal. So the key about ordinal measurement is the word order. That's where it comes from. And ordinal really is counting. So how much pain are you in on a scale of 1 to 3? 1 is none, 2 is some, 3 is a lot. What kind of math can I do with that? I can't do averages. If I average out and I get a pain of 1.7, what does that mean? Average pain of 1.7. I don't know if, I know that 1.7 is somewhere between 1 and some pain, none and some pain, but I don't know how much it is. Is it really 70% more than none? I don't know. So I can make a lot of assumptions. This is going to help me a lot. So there's not a lot that I can do with this. The distances between the two may not be the same. The distance between none and some may not be the same as a difference between some and a lot. Or maybe 4 is too much. Just between a lot and too much. I have no idea. So very often we use Likert scales. You know what Likert scales are? Likert scale surveys. How do you feel about how much tuition did you pay this year? Too little, just enough, maybe too much, and a hell of a lot too much. Right? So a Likert scale is a scale of opinion that goes from one end to another, usually with categories in them. Right. So a Likert scale would be the Ordinal scale. Really hard to do stats, but they exist. If I ask you, how many rooms are there in your house? Is that a continuous measure, or is that a categorical measure, or is that something else? How many rooms are there in your house? Tough one, isn't it? I haven't given you enough options, except for this one. I gave you an ordinal option. It's ordinal, right? Because I can count 1, 2, 3, 4, 3.5 rooms. Doesn't mean anything. It does to a realtor. They'll say, oh, 3.5 bedrooms here. What does that mean, 3.5 bedrooms? I can sleep in it or I can't. Right? So it's 4 rooms. So right, that's what I'm talking about here. Right? So that's what ordinal scale is. You can rank them, but you can't do anything in between with them. Between 1 and 2 doesn't mean anything. Between 3 and 4 doesn't mean anything. Next down is interval measurement. So these next two, interval and ratio, the last two, interval and ratio in the real world, we treat them pretty much the same. So this red bit here, I point out that in the real world, we would just call these two continuous. But in the textbook, they're big on distinguishing between interval and ratio. And for the purposes of being scholastic and examining exactly how we measure things, we're going to distinguish between the two as well, because that will help us choose our statistical test. So interval and ratio. So the difference between them is this. They're both continuous, meaning there is stuff in between, meaning, 25.4 has meaning, 25.43 has meaning, and so forth. But they have one distinguishing characteristic between the two, and that is a rational zero. What does that mean? Think about temperature in Fahrenheit, right? Do you know what the boiling or the freezing point of water in Fahrenheit is? Well, I love the metric system. It's so imbued in us now we don't know.
44.
Nope. Close. It's 32. So 32 Fahrenheit is the freezing point of water. Why? Because Fahrenheit people, I don't know. That's what they chose, right? In Celsius, we chose 0. So in Fahrenheit, does 0 mean anything? I have 0 degrees Fahrenheit. It's pretty darn cold. It's like minus 32 around there in Celsius. Does it mean anything? 0 Fahrenheit means nothing. It's not a rational zero. It's made up. Okay. On the other hand, 0 Kelvin, does that mean something? Yeah, 0 Kelvin has a real world meaning. If I say 0 height, does that mean anything to you? If I measure your height and I get 0, does that mean anything? Yeah, it means you're a splotch on the ground. That's meaning. Or if I measure your height and I get -4. -4 centimeters right. It's not realistic, obviously. What it probably means is you're hanging upside down by measuring your feet to your upside down. Yeah, it has meaning. So the distinction here is one of them has a rational zero and the other one doesn't. Interval measurement does not have a rational zero, but it has all the other great characteristics of continuous measurements. Like the difference between 70 and 75 is the same as the difference between 75 and 80. So at every step along the scale, the differences are the same. So with ratio, though, there is a rational zero. So this is our favorite kind of measurement. This is what we always assume our data is like, even though it rarely is. Okay? So it's our regular numbers that we can do wonderful math on. Like age has a rational zero, your height, your length, your weight, all that wonderful stuff. We care about health sciences. That's ratio. So we can do everything with ratio. We can do almost everything with interval. We can do a lot of stuff with ordinal. We can do like 1 or 2 things with nominal. So very often, though, we will begin with 1, and we'll convert it down to something else. For example, we begin with age, and we will convert it to age group. We'll count down 4 steps there. Why? We've given through the example already. Maybe the rental agency only cares about over 25 or under 25. So we've lost a lot of power for the purposes of applying a real world function on it. That's the takeaway message here. Two takeaway messages. Well, three maybe. The first is distinguish between those four things. The second is we lose wisdom as we move from one end to the other. And the last is sometimes we want to do that anyway. That's what I said right there. This table kind of summarizes their characteristics. A little bit later on. Right, moving on to another topic. Are we okay with measurements of levels of measurement? Yeah. Good. Our new topic is around sampling. So a lot of what we're going to end up talking about in inferential statistics, which I will define in a second, is around doing stuff to a sample of data to learn about a larger population. So maybe I do things to you people, well, to data about you people, in an attempt to learn about the university as a whole. Maybe I want to figure out the average age of everyone in this room. And I will do statistics on that average age to estimate the average age of all the students in the university, because I really can't have access to all the students. I only have access to you. So the real world is I can't, if I want to learn about the Canadian population, I can't ask all of Canada a question. That will be a census. Right? I can only ask a sample. That's a survey. The difference between a survey and a census is everyone, survey is some. Okay? So a lot of what we do at inferential statistics is taking some and estimating around the whole. What we're hoping to do is to get a sample that represents the whole. So this big blue thing is our reference population. The reference population is the people we care about learning something about at the end of the day. Maybe I care about the average age of all the students in this university. So all the students in the university are my reference population. I only have access to you. You're my sample, right? So the example I have here, if I compute the average number of women in this class, I can generalize to say, let's say they're about 75%, 80%, maybe 85% women in this class, then maybe I'll conclude, oh, the entire student population must be 85% women. Would that be true? Would not be true, right? More like 60% women in the student population here. So this class is not representative of the entire university, but I'm assuming that it is. So it's possible for me to reach into this empty bag of all the classes I could have choose from, choose you guys, and get an orange bit, assuming it actually applies to the blue bits. So in this case, this is not a representative sample. And you are not a representative sample in terms of gender distribution of the university. So that's the risk that we take when we do sampling stuff, is we may not get a representation of the people we're trying to extrapolate to. So you go into that more deeply in your research methods class and epidemiology. But it's important to get that nuance when we do inferential statistics. So, sampling. We have several levels we're going to get to before we get our sample. We have our target population, and then we have who we can access. If I'm trying to generalize to the entire university population, who do I have access to? Well, only the students that I teach I have access to. I teach 4 classes. You're one of them. So these 4 classes are my accessible population. And I only have access to the ones who show up. So they're my sampling frame, we're going to call that. And from the ones who show up, I'm only going to choose some from this class. So you become my sample. Automatically, I've gone through several levels there of losing people. That's going to affect how much I can extrapolate and learn about the population. The statistics will be affected. Okay. So here's an example here. Here we're trying to learn about the American population. So the reference population, sometimes called a theoretical population, is all of the United States. That's what I want to generalize about. And I'm going to do a telephone survey. I'm going to call up a bunch of Americans and ask them, I don't know, what kind of pop they prefer, Coke or Pepsi, right? So who would if I'm doing a telephone survey, who do I have access to? Yes?
People who have phones.
People have phones, exactly. This is the biggest problem with telephone surveys. People have phones. So the people that don't have phones are the homeless, the phoneless, right? All those people, automatically, they're out, right? Then I have the ones I'm going to call. How do I get these numbers I'm going to call? It's actually, you can buy them. Telephone companies will actually sell your number. Is that horrible? That's how you're getting called by telemarketers. Someone has sold your number to the marketers. So we buy these blocks of numbers, and we randomly select a bunch of them to call. So suddenly, the ones that weren't sold to me are not in my frame. Okay, so they weren't sold to me because they're commercial numbers, or you have paid extra money to be unlisted, or whatever. Right? Now I'm going to call them. Who's going to answer? If a stranger calls your number, do you answer it now? You screen it, right? Nobody answers calls anymore. So only the stupid people who answer the phone are going to answer it. Right? Usually old people. So a lot of our telephone surveys are skewed towards the elderly, A, because they got landlines, and B, because they answer the phone. Nobody else answers the phone. So keep that in mind. So suddenly in my study are a bunch of old people who have landlines and who allowed their phone numbers to be sold to marketers. Okay? Is that a representative sample of the people I'm generalizing to? Probably not. So recognize that there's going to be biases implicit in all this. I'm still going to do a lot of statistics on this group to generalize to that group. A good statistician will modify my analyses to account for some of these biases, but very often we don't. Okay. We'll do more about sampling later. Yeah. Okay, so now let's talk about descriptive stats versus inferential statistics. So the layperson, when you say statistics, they think of descriptive statistics. Things I do with my sample. X% of you are female, right? The average age is this. The average height is this, whatever. Anything that I do with my sample is a description of that sample. That's descriptive statistics. That's easy. That's grade 9 stuff. Inferential statistics, this is the challenge. This is what I want us to work on this semester. This is when we do things with our sample to infer conclusions about the reference population. And there's some theory there that we're going to wrestle with for a couple of weeks that really doesn't matter. It doesn't matter in the sense that how you apply the tests is not going to change, but intellectually I want us to try to figure out what that means, because it's kind of fun, and it shows the magic that is statistics to get the philosophy of what we're trying to talk about with inferential statistics. That takes us to a definition here. The words, is that a question? Okay. The words parameter versus statistic. So the layperson says statistics. Oh, like X% do this, whatever. Okay, fine. But technically, the word statistic refers to something I've measured in my sample. The word parameter refers to the same thing in the reference population. So if I measure the average age of you people, and I get 25 years, let's say, 20. Damn, you young kids. Yeah, 20. I remember 20. If I get 20 as your average age, that's my statistic for the sample. If I then figure out, using whatever technique I'm going to use, that probably the average age of the university population is 20 as well, that's a parameter. So a statistic is used to estimate a parameter. Some very important distinction, especially around the terminology we're going to use interchangeably going forward. Okay, we use the statistic to estimate the parameter. Sample here: the average daily calories consumed by all children's in Toronto. Children's in Toronto is a parameter. Now, the average calories consumed by 300 kids in one school in Toronto had access to. That's a statistic. I'm going to use that to write my report on that. Okay. Programs. You're going to, in the lab, work on a program called SPSS, which is the default program used by most social scientists. I forgot what it stands for. And the reason we chose SPSS is, one, it's pretty easy in general, and two, we have a campus license for it, so we're allowed to use it. A lot of the things you can do in SPSS, you can also do in Excel, too, so you can go home and play in Excel. You can purchase a student version of SPSS, I think for $20. It's hobbled, it's limited to what it can do, but if you want to learn on it at home, you can do that too, or you can buy a full license for several $100. I don't recommend that. So at SPSS is what you're going to learn in the lab. There's a free thing called R. So R is the open access version of S, because statisticians have no sense of humor. Right. So was a corporate commercial program that we used to pay for, and some clever folks developed a free version of S called R, because it's not quite as good as S. It's one less than S. It's R. Right? So you can download R for free. R is great. R has gotten so good over the years. It's better than S. It's actually really darn good. So we don't teach R here. But if you're looking to really build a career on this, you can actually download it yourself and start playing and teach yourself. SAS is another of the big platforms. You can build a great career learning to program in SAS. So epidemiologists live on SAS. One of my first jobs, I was a consultant for the federal government of the U.S. It was all entirely SAS programming. SAS is the foundation for a lot of corporate work. It's really quite lucrative if you can, get your mind around SAS. SAS is a pain in the ass. That's why it rhymes with ass. SAS, pain in the ass. Comedy gold. No one's laughing. But there's a whole host of other programs you can use too. But SPSS is what we're going to use here. Be aware that it is limited in some ways. And if you're going to go further in your career, you have to add on some more skills. But you'll enjoy it. That's all today. So no homework. Just try to do the stuff, and we'll see you on Friday. All right? Cool. Signing off.